Mm, Hi everyone, welcome again to this video on vector analysis. In this video, we'll discuss integration of vector functions, in particular surface integrals. So in the previous video, na-discuss na natin yung line integrals. So ngayon naman, ang pag-uusapan natin is more on surface integrals. So hindi ko na patagalin pa, let's start. So para i-define natin yung surface integral, uh, ay magawa muna tayo ng uh, analogy ba? Okay, analogy. Consider we have here a water flow. So, let's see, meron tayong water flow, no? Water. Okay. So ito ay, let's say, ito ay hose. So, may dumadaloy dyan na tubig. So, yun, medyo kumulob lang. Dahil bumabagyo ngayon. Okay. So we have water flow on a hose with the cross section of S sub 1. Hindi natin alam kung anong cross section yan. Baka mamaya circle or oblong or malay natin kung square yan, no? Pero basta cross section siya dyan. If the fluid na dumadaloy dyan has a constant mass density, rho, tapos meron tayong surface area o yung ating area, cross section, and yung velocity ng fluid, makukuha natin yung mass flow rate using this relationship. No? Ang sabi, the mass flow rate is okay, the mass flow rate is equal to the mass density times the cross-section area times the velocity. So, ang unit natin dyan is kilograms per second. So, let us assume na we take the same hose, but we cut it at an angle of theta. So, let's say, kinuha natin yung hose, kinat natin yan into theta. Ito na yung result niya, no? Yan. Tapos medyo yung kinuha nating hose, medyo mas mataba ng kaunti. Kaya iba na yung kanyang cross-section area. We now have S sub 2 as yung cross-section area natin na mas malaki kumpara dun sa una. We still have the same velocity flow rate. We can now write yung ating mass flow rate equal to the mass density, constant naman yan, yung cross-section area natin, which is S sub 2, and then yung V times the cosine ng angle kung saan natin yan kinat. Dahil ang lalabas dyan is, dito yung ang gusto lang natin malaman is yung projection natin doon sa normal sa area. Okay? So, yun yung mass flow rate na kailangan natin. So, instead of using these scalar values, okay, we can also rewrite yung ating equation using yung dot product, no? Same na same to. Dun sa pinag-aralan natin, we can replace yung V cosine theta with V dot the normal vector n, right? To get yung ating V cosine theta. And if we want to get yung ating total na mass flow rate at any given point dito sa host na to, isasum natin lahat yung mass flow rate na yan. So, summation from point 1 hanggang kung saan man yan, ng mass density, velocity at a given point, dot, n, uh, n hat, times yung ating delta S sabay. Yun yung ating ds. Diyan papasok ngayon yung ating ds if infinitesimally small na yung ating surface area. So, we now have this equation or expression for the rate of flow ng variable velocity fluid through an arbitrary surface provided that the velocity is known, okay, and the norm and it is normal to the surface na i-evaluate natin. So, i-generalize lang natin yung natutunan natin. So may background akong kulog. Pasensyahan nyo na. I-rewrite lang natin, i-generalize lang natin yung nakuha nating learnings dyan sa example na yan. Let us rewrite yung formula na yun in terms of a general vector A. Yung A na yun, yun yung ating field. So, ulit tayo. The rate of flow of vector field A can now be written as this expression. Okay? Ayan. So, the rate of flow is equal to the surface integral of A dot the unit vector n ds. Dahil yung vector n naman ay equal naman yun sa 1, pwede na nating alisin. No? Pero, let us take note na inalis natin yan, dapat sure tayo or yung ating direction ng ating surface integral is perpendicular doon sa ating surface. Yan. And it follows the right-hand rule. So, ayan. So, same din sa kung closed path naman, gagamitan lang natin itong symbol na to. Ayan. Yung may bilog sa gitna. To get the closed surface integration ng particular vector na yun. Sige. Try natin mag-solve ng isa. No? So again, the surface integral of a vector is the flux of this vector through the surface. It can be written as this form. Itong nakabox na to, yan yung ating gagamitin sa pag-solve ng mga surface integrals. So yung line integral kanina, so kung mapapansin natin, integral dito L, then yung ating vector dot dl. So yung ating dl kanina, or iba-iba yan, Cartesian, cylindrical, and spherical, right? Ganon din dito sa surface integral. So we need to recall yung mga formulas and relationships na na-define na natin doon sa mga previous videos. So, ipo-pull out natin yun ngayon. Like for example, sa Cartesian coordinate system, yung ating dx or surface differential surfaces, ito yung formulas na gagamitin natin or expressions na gagamitin natin. Sa cylindrical naman, ito, r hat, tapos r d phi dz, phi hat dr dz, z hat r d phi dr. Yan. Then sa spherical naman, sulat ko lang dito ulit, ito yung ating gagamitin. Pakitandaan or kung meron kayong notes, isulat na natin yung formulas na to. Then eventually in the future, gagamitin nyo rin yan dahil itong mga surface integrals, magagamit yan sa electromagnetics. Okay? So let us solve a problem here that a vector field is given as A is equal to phi hat 5r. We are to calculate the flux of this vector through a surface defined by r less is greater than 0 less than 1, so between 0 and 1, and yung z daw is between 3 and between negative 3 and 3, and yung ating phi, sabi, constant daw yan, and we are to assume that the vector produces a negative flux through this surface. So tatandaan natin yung negative flux na yan dahil meron niyang meaning o binibigyan tayo ng hint kung paano natin isolve yung particular problem na to. So, knowing yung problem, ano na susunod natin gagawin? Ang gagawin natin is we will solve this vector field or the flux using the formula na dinescribe natin kanina. Okay? It is the surface integral ng vector na yan or dot product with the differential surface. And yung ating differential surface na gagamitin, d sub s, okay? Or ds, it is with respect yung doon sa ating phi, no? Yan. Kasi yung ating given nasa phi. Kung mapapansin natin, nasa phi. Para pag nag-dot product tayo, meron tayong makukuha. Okay? So yung ating differential surface with respect to phi is equal to phi hat dr dz. So medyo madali lang siya dahil walang complication dun sa formula ng ds. So ano nang gagawin natin? We will substitute itong dalawang vector quantities na to sa formula natin. So with that, we now have the surface integral phi hat 5r dot negative phi hat dr dz. Naglagay ako ng negative, bakit? Kasi ang sabi, assume that the vector produces negative flux. Yan, negative flux kasi yan. Ibig sabihin yan. Okay. So, paano na susunod natin gagawin? Ipe-perform na natin yung ating dot product. Okay. So, ano na matitira dyan? It is now equal, the flux is now equal to the surface integral ng negative 5r dz, dr dz. Yan. So, ito, meron na tayong limits. Kung limits na ang pag-uusapan, meron na. Kaya pwede na natin yan i-transform into the integral. So, paano ba yan ginagawa? So, we will introduce or we now have a double integral in this particular problem. So, equal ito sa integral sa part ng r. Then, sa part naman ng z, meron din. So, negative 5 dz times r dr. Yan. So, pinagsama ko lang muna yung RDR dahil sa pangalawa pa siya. Okay. Although, kung ang question nyo is kung pwede bang mauna yung R, pwede naman dahil pwedeng baliktad. Pwedeng mauna yung R bago yung Z. Well, in this case, inuna ko muna yung Z dahil wala naman siyang effect dun sa R pag solve natin. Pero kung meron effect or yung ating mga integrals is variable, ibig sabihin meron, let's say, meron yung R dyan, kailangan alam natin yung pagkakasunod-sunod ng ating integration. Okay? So, kinulayan ko na muna yung integral natin sa z dahil yun yung una nating ipe-perform. Okay? So, in this case, ang sagot natin, magiging sagot natin dito is negative 5z evaluated from negative 3 to positive 3. And yung sagot dito is gagamitin natin itong dito sa RDR. Okay? Yan. So, negative 5z evaluated from negative z or negative 3 to 3. Ano na susunod natin dyan? Evaluate na natin. So, that will give us the integral from 0 to 1 ng r. Then, ito ay negative 15 minus positive 15 RDR. So, lumalabas pala dyan ay negative 30 RDR. Okay? Yan. So, dito, kung mapapansin natin, isa na lang yung ating variable. R na lang siya. So, straightforward na to, pwede na nating evaluate yung integral from 0 to 1 of negative 30 RDR. And yung integral ng RDR is actually R squared over 2, right? Plus C. Pero dahil meron naman tayong limits, hindi na kailangan yung plus C. So, ano na sagot natin dyan? Itong nasa green, so negative 30, then times r squared over 2, evaluated from r is equal to 0 to 1. So, substitute daw pala natin yung 0 and 1 dito sa r. And that will give us a flux of negative 15 kasi dun sa 1, naging 1 half na to, no? Ito naman 0. Kaya 1 half times negative 30 is negative 15. So, sabi dito, the vector produces a negative flux through this surface. So, yung sagot natin is tama. Okay? So, that's a good example kung paano natin i-evaluate yung or paggamit ng mga close surface integrals. Okay? I hope meron kayong natutunan na kaunti dito sa video na to. And kung meron kayong question, comment lang kayo dyan sa YouTube o sa channel para masagot natin. Okay? So, meron pa tayong susunod na video na related dito sa surface integral. Okay, meron pa tayong mga susunod na example. But for now, yan muna. Yung isa na yan. And to summarize, nagkaroon lang tayo ng analogy to define before we define yung surface integral. Meron lang tayong analogy. And then we define yung ating surface integral and we work on a sample problem to illustrate yung paggamit ng mga surface integral. Okay? So, that's it. Maraming salamat. Keep safe and see you on the next lesson.